Hello everyone, welcome back to my channel. So today in this episode we are going to discuss about the structure of atom. So as we know what is meant by atom. So in our previous grades like in ninth grade and 8th grade we were studying about the atom is the smallest unit. We call it as the smallest unit of a particle. So it is said to be called as the smallest unit of the particle. So that is which cannot be divided. That means it's indivisible. So the atom is the smallest unit of a particle which is indivisible. That means which cannot be divided. But later on, the atoms can be divided into three subatomic particles, which we call it as first as the proton, which is a positive charge, and second is neutron, which has no charge, and the third one is electron, which is the negative charge. So many scientists had described many theories like John Dalton, Rutherford, J.J. Thomson. So everyone has explained a separate structure of atom. But the very most familiar is the Bohr's atomic model. So the Bohr's atomic model is very much familiar as it is started the starting base for the structure of an atom. So in his atomic model, that is the Niels Bohr. So the scientist's name was Niels Bohr. So in his atomic model, he explained that the protons and the neutrons both combinedly are called as the nucleus, and these nucleus are present in the middle of the atom, which are present in the middle of the atom. So the protons and the neutrons are present in the middle of the atom, that is which we call them as a nucleus, and the electrons revolve around the nucleus in a specified path. So they revolve around the nucleus in a specified path, just like how the planets revolve around the sun. So the same thing also he had made a theory which is the Bohr's atomic model, and he named that the protons and the neutrons are combinedly called as the nucleus, which are present at the center of the atom, and the electrons, which are the negative charged particles. So these electrons revolve around the nucleus in a specified path, and these paths are called as shells, or what we call it as orbits. So in Bohr's atomic model, what first he explained is, so the electrons revolve around the nucleus in a specified path. So they revolve around the nucleus in a specified path, and he named that path as known as orbits, or it can be called as shells. And the second postulate, so the first postulate is the electrons revolve around the nucleus in a specified path, which are called as shells or orbits. And the second postulate of the Bohr's atomic model is he named those shells as K, L, M, N, and so on. That is, he named these shells as the first shell, which is represented as the K shell, the second shell, which is represented as M shell, and the fourth one, which is represented as the N shell. And he named the numbers. He has given the numbers which are denoted by N is equals to 1, 2, 3, 4, and so on. So as these shells are named as with the alphabetical uh, letters which are K, L, M, N, and so on, and they named as the numerical values, that is N is equals to 1, 2, 3, 4, and so on. So this is the second postulate of the Bohr's atomic model. And coming to the third postulate of the Bohr's atomic model is, so when an electron gains energy, so when it gains energy, it jumps from it jumps from lower orbit to higher orbit. So for suppose this is the nucleus and this is the first shell, or what we call as the ground state. We can call it as the ground state, and this is the second state, which we call it as the excited state. The excited state, not excited state. So as the nucleus is present in the center of the atom, and this is the lower orbit, which is called as the ground state, and this is the higher orbit, which is called as the excited state. Now here we have an electron, and this electron, when it absorbs energy or when it gains energy, so when it gains energy, so the electron which gains the energy will not be staying in the ground state. It moves on to the higher orbit, that is. And the third postulate is the electron, when the electron gains energy, so it jumps from the ground state to the excited state, that is from lower orbit to the higher orbit. And as well as the last postulate of the Bohr's atomic model, so when an electron loses energy, so it jumps from higher orbit to the lower orbit, or what we can say, so when an electron jumps from the higher orbit to the lower orbit, it loses some energy. So this losing of energy, we write it as h nu. That is nothing but energy, which is the Max Planck equation that will be coming on to the later. So the energy which is being released here will be in the form of a light energy, and or we call it as a spectrum. Now what is a spectrum? What is a spectrum? So spectrum is nothing but a group of wavelengths, different wavelengths. So a group of different wavelengths is said to be called as a spectrum. Now if we take a white light, so a white light is a combination of 7 colors with 7 different wavelengths. Okay, not exactly the 7, we cannot say with the exactly 7, but those 7 are being identified. Like if we take a white light, so here the white light is a combination of 7 colors, that is violet, indigo, blue, green, yellow, orange and red. So it is a combination of 7 colors, and the violet color, which has the low wavelength, so which is of 400 nanometers or it can be written as 4000 angstroms. And when coming to the indigo, blue, green, yellow, orange, so here from here onwards the wavelength get increases. And when coming to the red, so red is the high wavelength color, and it has 700 nanometers, or it can be called as 7000 angstroms. So that is the energy which is being released over here will be in the form of a light energy, or it can be called as a spectrum, and those spectrum will be in the form of different wavelengths. So the spectrum which is being released over here is said to be called as emission spectrum. Emission spectrum. Why? Because as the energy is being emitted over here, that is the energy is being emitted out or loses out. So here the spectrum which we get here is said to be called as emission spectrum. And we have another type of spectrum which is called the absorption spectrum. That is here, that is when the energy absorbs the energy on the first part, that is coming to the third posture, that is when an electron gains energy or when it absorbs energy. So there also that spectrum is said to be called as the absorption spectrum. And when it loses the energy, then that is when it emits the energy, which is said to be called as the emission spectrum. So the spectrum here we have two types. One is the absorption spectrum, absorption spectrum, and another one is the emission spectrum. Okay, so most probably they always ask about the emission spectrum. So emission spectrum is nothing but when an electron emits the energy coming from higher orbit to the lower orbit, from the excited state to the ground state, the energy which is being released here will be in the form of light energy or the spectrum. That spectrum is said to be called as the emission spectrum. So this is about the complete view of the Bohr's atomic model. So here Bohr's atomic model also has a failure. So that is, what is the failure? This spectrum is explained only for the hydrogen molecule, that is the hydrogen atom. So it is explained only for the hydrogen atom, but it didn't explain for lithium, beryllium, boron, carbon, that is what various elements he didn't explain. He explained only for the hydrogen atom. And also he didn't explain about the Zeeman effect, and also the Stark effect. So what are these Zeeman effect and Stark effect? So Zeeman effect is the splitting of light, that is these spectrum lines are being divided into a fine spectrum, that is these spectrums are again divided into fine spectrums. So how can these fine spectrums divide? Only with the help of the magnetic field and electric field. So the released spectrum is again being done into a fine spectrum only with the help of the presence of the magnetic field and another one the electric field. So the splitting of lines into a fine spectrum in the presence of magnetic field is called as Zeeman effect. And in the same case, the splitting of lines into fine spectrums that in the presence of the electric field is said to be called as Stark effect. So he didn't explain about the Zeeman effect and the Stark effect, which is the one of the failure of the Bohr's atomic model. So again there is the orbits which has been explained, that is the concentric circles. So later on these concentric circles were little bit corrected with the sommerfeld, which we call the another model which we call Bohr sommerfeld model. Bohr sommerfeld model. So in the Bohr sommerfeld model, a scientist named called Sommerfeld, he had made a little bit corrections in the Bohr's atomic model. So what are the corrections is, in Bohr's model, here we see the concentric circles. So K, L, M, N, so we see the concentric circles. But with the light corrections, that he made those uh, shells into an elliptical path. Like, so this is the nucleus. So he left the first shell, or the first orbit. So that is the K. And next, from the second orbit, he had made them into the elliptical orbits. And next, coming to the third, and coming to the fourth. So what we can say is here, the K shell, L shell, M shell. So the Bohr sommerfeld model had little bit modified into elliptical orbits. So he had made modified into the elliptical orbits. But in Bohr's model, he named them as the shells, which are a concentric circles. But as it was a little bit limitations to explain the further the fine spectrums, so the Bohr sommerfeld has converted them into the elliptical orbits. That is, the path of the orbits, the path of the shells are not in a circular form, but they are in the form of elliptical orbits. So later on, the Bohr sommerfeld model was also didn't explain the exact path of an electron. So they didn't explain, that is the limitations is, they didn't explain the exact path, the exact position of an electron in an atom. Position of electron in an atom. So later on, as many scientists had made many contributions upon the exact position of electron, so a scientist called Max Planck had derived a model which is called as quantum mechanical model. So quantum mechanical model of atom. So Max Planck has modified the atomic model into a quantum mechanical model of an atom, and in this he had made many contributions that to find out the exact position of an electron. So how he made to find out the exact position of electron is, he just made to find the electron, like if we are in a dark room. So if we are in a dark room, to find any specified object, we need to we need to put a torchlight, or we need to put on the light upon that object so that it can be viewed, right? So the same thing also, Max Planck had got an idea about that. We should put upon a light upon the electron which is revolving around the nucleus, so that we can find out the exact position of the electron. So what he had done is, he had taken a light which is of shorter wavelength, not short wavelength, shorter wavelength, incident upon the electron. So when the light with the shorter wavelength, when it is been incident upon the electron which is revolving around the nucleus, so nucleus, for suppose, most probably will be we see this atomic structure of an atom in Google also. So for example, here we have an electron, and a shorter wavelength of light is been incident upon this electron. So when a shorter wavelength of light is been incident upon it, so it disturbs the motion of an electron. So the motion of electron which is been revolving around the nucleus, it get disturbed, and simultaneously the position as well as the velocity of electron, they cannot be measured accurately. What I am saying is, with the help of a shorter wavelength, the motion of an electron is being disturbed. So when the motion of electron is disturbed, the position which we cannot make it exactly, as well as the velocity also cannot be measured exactly. So this was clearly explained by Schrödinger, Erwin Schrödinger. Erwin Schrödinger came and explained and given a final model of the quantum mechanical model of an atom, that these electrons are in a properties, that is, these are made in a certain to understand this, what he had made is the electrons are thought to exist in a particular region of a space around the nucleus of a given instant of time. That is what he given is of a space around the nucleus where the probability of finding the electron is maximum, is called an orbital. So this was the final conclusion of the Erwin Schrödinger. So Erwin Schrödinger told that there is a region of a space around the nucleus where we can find out the electron. That is, the probability of finding an electron will be maximum at a certain area. So those are said to be called as the orbitals. So orbitals which we call it as s orbital, p orbital, d orbital, f orbital. So what are these orbitals will be explained in the next episode. So these orbitals are the place or the region where we can find out the electron maximum. That is, the exact position cannot be determined, the exact velocity cannot be determined, but we have a probability of finding the position of electron with the help of this orbital. So our orbital is nothing but the region of space, that is a space which is around the nucleus, where we can find out the electron. So that is a maximum problem. We cannot say that that is the exact position. No one can say the exact position that at this particular point we have an electron here which revolves in a particular path. We cannot say the exact position as well as the exact velocity of an electron. As I told you before, if you want to find out, incident a light upon it, right? So the light with a shorter wavelength, when you incident upon it, the position and the velocity of the electron get disturbs. So when it get disturbs, we cannot measure accurately, but we can find out the maximum probability of an electron. That means the place where we find the electron more, that is region of the space, is said to be called as orbital, which was explained by Erwin Schrödinger. So in this episode, what we have discussed is, we have discussed about the structure of atom. That is, we have discussed about the definition of an atom, that we have proton, neutron and electron, and as there were many models, most probability and the famous model, which is the Bohr's atomic model. So here these are the four postulates of the Bohr's atomic model. And so Bohr's atomic model was almost successful, but he had a limitation or a drawback to explain about the Zeeman effect and the Stark effect. And also the spectrum was explained only for the hydrogen atom, but not for lithium, beryllium, helium and the remaining elements. And next on came to the Bohr Sommerfeld with the little corrections in the Bohr's model. Sommerfeld had made the circular orbits into a elliptical orbits, but what is the limitation in that is he couldn't find out the exact position of an electron. So later on, the Max Planck came with a model called quantum mechanical model of an atom. So there, what he had derived it, to find out the position, we have to insert a shorter wavelength upon the electron. So if it is done like that, the motion of electron will be get disturbed. So it moves on to in a different direction. That means it get disturbed, and the position of the velocity cannot be measured accurately. So later on, the Erwin Schrödinger came with a model, with the same quantum model, and he named the region or the space of which is present around the nucleus, where we can find out the electron in that place. That is, the maximum probability of finding an electron in that place is said to be called as the orbital. So this is about the structure of an atom and the atomic models which were explained till now. And later on, to the recent technologies, cloud electron, that all we have that we will be learning in the next episode or next grades. Thank you for your time. Please subscribe the channel and wait for the many interesting videos. Thank you.